thinking about some things that would potentially be good sort of fodder for questions on the final exam. We're going to talk about why artists make code and why they use code-based tools, and in general, just kind of like what does art have to do with code, and what does code have to do with art? And it turns out quite a lot. It's a very sort of vital and kind of growing way of really making images, experiences, animations, videos, websites, objects for 3D printing. Pretty much if you can look at it or it can be processed through a computer, you can use code to edit it or create it. So we're going to start with a kind of genre of code-based art that's called generative art. And that's really just kind of a blanket term. Strictly speaking, generative art doesn't have to involve computer code. I do know a couple of generative artists who work exclusively with non-coded algorithms, meaning that they just use math. That's a thing that people can do. So, but probably about 99% of generative art is made with a computer these days. So we're going to kind of spend some time, talking about this, and just in general looking at a lot of art. And historical art that influences some code-based artists, and then also things that are being made, in the last couple of years. So if we think about what the whole idea of generative art is really just kind of a fancy way of saying that something was generated by a computer. And usually generative art applies specifically to work where the artist was kind of aware of the algorithms. So if you generate something in Photoshop, it's probably not going to be considered generative art, because you don't, you hypothetically speaking, in the general sense, one would not understand maybe what the kind of underlying code of Photoshop was. But if you use code to generate a similar result, then you could probably make an argument that it was indeed generative art. So it's usually programmed, almost always involves the use of algorithms. It's kind of hard to code without algorithms, so that's, almost a truism. And it says in the on the slide, and this is true, that it, involves some kind of randomness or some kind of element of chance. That's kind of a maybe like sometimes sort of quality. I would say if I were just kind of edit this slide on the fly, which I'm probably just go ahead and do that. I would say sometimes. I don't want to trip anybody up on the exam. No. So yeah, sometimes it uses randomness. Sometimes it can be completely regular. In other words, it could be a grid that has, no level of randomness or variation to it at all. And indeed, when we kind of think back to some of the early computer work, some of it didn't really involve any kind of randomness. Although, it is pretty common that generative art would involve some sort of chance or some sort of emergence is another way of maybe thinking about things that are kind of created by code but may be unexpected by the artists themselves. So there's a couple of myths kind of flying around about generative art. One is that if I'm an artist and I write code, I'm just crunching numbers, and there's basically zero human decision making, and zero sort of like what most people would consider, if we get really crazy old fashioned here, soul it has no soul. And so, I think people in, maybe my generation and ahead of that, into your generation, might not care that much or don't even know what that means. But it's something that I have heard a lot over the last, 20 or 30 years, that somehow, work that's made with code or work that's made with computers in general is somehow lacking some undefinable element that makes art awesome. And I guess another way of putting that would be, if you want to be really snooty and arty about it, it's lacking that je ne sais quoi, that I don't know what, in translation. So the other sort of kind of not so great myth that's going around out there and has been for many, many years about kind of computer-based and generative art is that the artist has zero control over what the computer or the machine is doing. And I think anyone who's ever used a stylus to draw a picture would think that sounds just absolutely absurd. Although I think with the code-based art, maybe the argument is that there's a like mental distance there that takes the artist so far away from their art, because of course the assumption in this argument is that they should be using a pencil or I don't know, a paintbrush or something. And so that the computer is actually the one making the art, and not the artist. And oh my goodness, that's just ridiculous on so many levels. I think it's a lot of these ideas are very kind of like almost like old-fashioned prejudices about computer-based art, but you do still kind of encounter them today out there. I think that the world is a really, really big place, and there are places in the world where computer-based art is kind of the default option. And everybody's doing it, and it's really cool. And Madison, Wisconsin is not one of those places. But we do have a lot of people that make really, interesting digital work. But there's also a lot of people who are in our art scene, at least in Wisconsin, and I would say the upper Midwest in general, who have, more traditional values about what makes a work of art good or bad. And so, these are long conversations that you could have with somebody about, why one work of art has value and why another one doesn't. And they do tend to be what we would call, like a philosophical rabbit hole, or like sort of a dead end, a black hole. So let's just move on and look at some computer art. Not yet. Sorry, I lied. So we're going to look at just a couple of quick works that influenced computer artists. And so one is this guy, Kazimir Malevich, and he's kind of amazing as an artist. He looks a lot like his work. This one in particular looks a lot like another artist who was more well known, named Piet Mondrian. And the whole idea between this of this kind of like suprematist thing was that he wanted to empty his paintings out of all content and have them be completely, like, I'm going to use the P word, pure geometry. And so he was actually doing that to support a political movement at the time. He was doing it to support the Bolshevik revolution. And so he became actually totally kind of co-opted by the communist revolution in Russia, and it went from making this sort of abstract art to making very straightforward propaganda paintings. the kind of propaganda paintings that you would imagine with, people in Red Square, tanks, and, Soviet flags and this kind of thing. So it was a very far stretch from this kind of much more aloof position that he took in the suprematist movement. But he did really influence many, many, many early computer artists. And we're also going to just kind of give one small nod here to Joseph Albers, and we haven't really talked about him at all in this class. And I think particularly as a sort of predecessor to computer art, he's super, super important. And you can see he's working on graph paper, so that's a really good sign that he's doing something that's probably working in a way that is designed to be replicated. And could be replicated by text. And so pretty much everything that Albers produced was in that vein. And the idea was that he and lots of other modern artists working at the time, wanted to separate the image from the instructions and the form that can create the image, so that the image can be reproduced or and when I say reproduced, I don't necessarily just mean like a print that gets mushed down and then another one gets mushed down. When I say it's reproduced, I mean it can be remade entirely. And so you also see in the kind of modern era artists who are working with things that this really looks almost exactly like what a generative artist would do today. This was Bridget Riley, and she pretty much founded this school of painting in the 60s called op art, which was based on using kind of line and form to create optical illusions, and not necessarily illusions. Like in this case, I think we could probably just argue that it has an optical energy. And then, of course, we also have Sol LeWitt, which was the sort of wrong question on the midterm exam, if anybody remembers that. The question was, what analog artist creates his work with instructions that is, similar to the way a code-based artist functions? And the answer is Sol LeWitt. Guess what? That's not going to be on the final. But his work is pretty... it was pretty fascinating and kind of groundbreaking for its time. He functioned as an artist like well into the 2000s, but he was really kind of known in the 60s. And what he became known for was not so much this, which was the result of his instructions. And by the way, this drawing would be like maybe like in a giant museum wall. It would be like 20 feet by 20 feet. There was a giant one in the National Gallery for a long time, a pencil drawing that they had us work on. Actually, when I was in graduate school, we all just drew these pencil lines based on these instructions, because that's kind of how the work is made. And it was up for a few years. But the whole idea behind Sol LeWitt's work was that he, somewhat like Joseph Albers, wanted to divorce the instructions from the form, or if we're being kind of academically fancy, from the instantiation of the kind of meta sort of script. So what are the instructions? Well, in this case, it's draw, a 6-inch grid with a pencil. From the four corners, draw, straight blue lines using crayon to random points on the grid. And then, so anyone who has this set of instructions can make their own Sol LeWitt drawing. And of course, if we think about the early days in particular of generative art, and to a certain extent even now, because generative art is not really a commercial enterprise, there is this sort of thread, that runs through computer programming circles that code should be freely shared, and as a way of allowing people to, build on other people's inventions, right? And so it's kind of interesting to think about, wow, what would we do if the whole world worked that way? I don't even know. So I think we've looked at this slide before, but I just want to remind you about George Neese, who, again, this is kind of like midway into the kind of early computer art thing, and he's making these sort of falling grids. Now, we should get to a point with code in the next week or two where we could make something like this. And we could make something like this, and it could probably be also animated. So we could make the blocks fall down. That would be pretty fun. So let's, there's something to look forward to. And, of course, Vera Molnar. And so kind of like thinking forward through some of this stuff, we have Casey Reese, who is the guy that actually invented the language that we're going to be looking at. But he invented it around 2001. So it's been around for about 20 years. And his compatriot, Ben Fry, in addition to making this data visualization, which is pretty funny, it's just a map of every street in the United States. He sort of, I guess, I would say maybe not founded, but he definitely wrote many books and sort of created the field of, computer-based data visualization. And so he's one of these rare academic types that is no longer working in academia. He's actually working in private industry now. It happens to people sometimes. They'll go and work for Google or something. So if we look at sort of what's going on, in the more recent times, of course, we've got data visualization, huge trend there. Casey Reese is really an artist who kind of borrows from some of the, I would call, traditions of early computer art. So he works a lot with something called emergence, where he'll make code structures intentionally to do things that he doesn't understand, or basically, where the code does things or produces a result that he was not expecting. That's kind of one of his hallmarks, and it's kind of a hallmark of creative coding in general. This is a much more kind of like, straightforward scientific application. And then we also have people like Jared Tarbell, who is really kind of like way out there on this sort of abstraction kick. And, you could look at one of his images, and if you don't know, it could be an abstract painting from like, the sort of German school in 1985. And I think that for me, that's actually one of the most exciting things about some of the generative art that's being made today, is that it doesn't necessarily have this stamp of like computer generatedness to it. You don't look at it and just instantly realize, oh, that was definitely fabricated with a computer. And so I think that, if we're looking forward, that's the type of work that we're going to be seeing more and more, is work that, maybe might not be as clear in its origins. So there's also right now, as we know, if we're kind of living, breathing human beings, there's a lot of interest in AI. And it does go beyond, Siri and my vacuum cleaner being smarter than me. It is kind of falling into art as well. And so you have people, I don't know if anybody remembers, like way back when we were talking about probably the history of art and technology part 2, I think, we were talking about this guy named Harold Cohen, who was making really probably the first artist to work with AI systems, where you could take 10 drawings of a tree, for example, and using machine learning, you would basically teach the computer what a tree looked like, and then the computer would make its own tree. So it's not just taking 10 trees and pulling them out of a database. It's basically, giving the computer like the language of what tree is. So in any case, lots and lots of artists right now are kind of following in his footsteps, and using AI systems to create both abstract and very concrete and realistic, or I guess we could probably also say that most of the AI generated work that's being made today fits within that idea of the uncanny valley, in that it's like, this is real, but this is like so disturbing. So this work by Ravi Bharat definitely falls into the sort of like abstract, end of the spectrum. Of course, this is actually just like not art. This is just a demonstration of, coming up with three basically, fully generated faces. And I think we can pretty much like, agree that they look pretty real. It's pretty good. So this was sort of, they start with a sort of seed population, and that's is basically a really great illustration of how these algorithms work. So it's definitely way beyond the uncanny valley at this point. And of course, then an artist gets a hold of it, and again, Ravi Bharat is, kind of the guy right now who's really working with stuff. But it's, I would argue that the computer in general, I know for a fact that if we're asking an AI system to draw a nude portrait, it would do a much better job if it were asked to. So I think that Ravi Bharat in particular, as an artist, is actually kind of aiming for kind of breaking some of these AI systems to generate a result that is like, nondescript is the wrong word, and uncanny is the wrong word. It generates a feeling of, I'm going to describe it in a colloquial way. I think he's really interested in having his viewers be like, what? And what I mean is that I think that he, this artist in particular, really wants there to be some disconnect in the viewer looking at the work to say, is that real? Was it made by an artist? Was it made by something else? And just kind of ask that question, like, what? It's my favorite question in the world, by the way. And again, I mean, I guess keeping the what going, we also have, Mario Klingemann, who, this is, illustrating a somewhat more sophisticated AI. I mean, but it still has a pretty high level of like nightmare fuel. In terms of, I would not want to wake up to any of these faces. My goodness, they're a little horrifying and a little wrong. And so, yeah, I think that idea of, AI kind of producing wrongness, that's actually where most of the artists are interested in kind of exploiting that. And there, in fact, are whole, speaking of internet black holes, yeah, don't go down that Reddit hole. That's all I have to say about that. Sorry, excuse me. And now we're done. So, if we were to kind of like, think forward to, the future about, where sort of generative art and code-based art is going, I mean, I think we can spend a minute thinking about that, I watched a lecture not too long ago of this guy out of Stanford who had basically been kind of arguing that he was talking about airplane safety, of course, airplane safety, but he was kind of relating airplane safety algorithms to how we make code as programmers and as people, just navigating through something that is text-based, right? And it has to be maintained, and it has to be error checked, and of course when you start talking about airplane safety, that's a serious stuff. And somebody does need to check the algorithms that control whether an airplane is flying or diving. And that's, of course, maybe the privilege of the artist, is that you don't have to have that level of, sort of life or death seriousness brought into your work, unless you really want to. But I think one of the things that this guy was saying, and it's a thing that I've heard before for a long time, is that in the future, code might not actually exist, that code actually is part of the problem. And of course, as a programmer, I consider myself a programmer. I worked as a programmer for, years. I was like, what? Like clutching my pearls. But yeah, I mean, I think there are a lot of people out there in computing right now that are sort of looking for fundamentally better ways to work with data. And I think that as soon as systems like that might be developed, you can bet that some artist is going to be in there playing around with it. And if I don't beat them to the punch. So I think that the takeaway here is that for everything that's happening that is technological, whether it's your Xbox or your Oculus or literally anything, there is going to be one or more artists trying to break it or do something interesting with it. And I would encourage you all, as you move out of this class, I would encourage you all to really start searching for people who are doing things that are of interest to you. We have a whole lot of, not to work a cliche, but we have a whole lot of technology at our fingertips. And you can certainly find people who are interested in the same things as you, and maybe doing it with technology, with augmented reality, or with some system that is fairly new out on the marketplace. So I'll see you soon in a code demo near you.